So the very first thing I want to show you is that this is what you'll get with the assignment. So just like assignment 3, you'll be given a menu. This one is just slightly different color. And then you'll be given this. So you do have up here, you have debug settings, animations, entity manager. This is part of the assignment that you have to do. It's not worth very much, but the reason for that is because you've already done it in assignment 3. And you can literally take your assignment 3 code, copy it, paste it there, and it'll just work. It should. But there's no controls implemented or anything. You're just sitting here. This is Link. This is just the standing down animation, and you've got some hit points and stuff up here, but I'll show that when we get to the code. But yeah, that's what you get when I give you the assignment, and now we'll see what you should have by the time the assignment is done. So this is the solution. There are sound effects in this assignment, and there's also music. For the solution code, I turned off the playing of the music, because if that was playing for this entire lecture, it would get incredibly annoying. Also, the sounds are very low right now, but I'll turn it up for 1 second. There are sounds in the game, but I'm turning them down because that will be like ear-blastingly loud on the video, which is what I want. I don't want that to be super loud. So just keep in mind that there are some sound effects. Okay, so this is quite obviously a clone of the original game for the NES, The Legend of Zelda. I've taken some sprites from there. I've taken some sprites from other places as well. But now we're moving from a platformer into an arguably simpler type of game to create, which is just a top-down sort of action RPG type of game. So here you are controlling Link, and if I can just zoom in for a little bit here. So this is definitely not Link. And you can see here that Link has a few animations. So for example, there's left and right. So in this assignment, as well as assignment 3, left and right are simply mirrored of each other. Now, this is fine for this type of game, but just keep in mind, in real life, if you have a sword and a shield in your left and right hand, you can't simply just mirror it, because it'll like, oh, now his sword is in his left hand, right? So if I look this way, it's fine, because the shield sort of disappears in this, and so you can't really tell the difference between left and right. But you can't just mirror up and down, because one shows the back of Link and one shows the front of Link. And so there are 3 different animations for this. In this assignment, we also have health. So here I'm showing a health bar, and each of these little rectangles here are showing the maximum health, which is 3, and 3 of them are currently filled up, and so the current health for Link is also 3. I'll get into the damage and hit points a little bit later. But as you can see, as I'm moving around, in this assignment, we have rooms. And so this is a room or a grid-based type of game. We went over one of those types of games in the last lecture on cameras when we talked about that type of view. So if I walk off of the left side of this room, I go into the room to the right. And there's some stuff there. I'll talk about that in a bit. If I move up, there's another room up here. And if I move down and to the right, there'll be other rooms there. So one of the things that you're going to have to do in this assignment is figure out how to position the camera such that you figure out which room that Link should be in, and then you position the camera statically on that room. There is also a second camera in this assignment, which is the follow camera. So I think if I hit the Y button, or if I hit this in the UI, it'll toggle between the room camera and the follow camera. And if I turn on the follow camera, you can see what a different type of game this becomes, right? Arguably much, much worse. So there are some games that you would actually want to follow around, like a Diablo type of game. But if the geometry of the world is described in this sort of room type setting, then it's a bit weird to have that follow camera going. But oh geez, okay, hang on. I'm gonna be fighting for my life this whole assignment. That just happens sometimes. But I just wanted that in there to introduce the idea of, okay, rooms and cameras and stuff. So, okay, this is a good time to introduce the hit points and damage in this assignment. So here I've got this knight following me. If I swing my sword, the sword is going to deal 1 damage to these NPCs. And if I deal enough damage, that NPC will explode and die. So I've just reused that animation from assignment 1. Yeah, sorry, assignment 3. Here you can see that I've got this other NPC here, and now let's talk about hit points for a second. So this NPC has like 8 health. My sword does 1 damage. And so every time my sword makes contact with that NPC, I take away 1 of its hit points. So the way this is going to work in this assignment is that every entity is going to have a damage component, and anything that can deal damage will have a damage component, and anything that can take damage will have a health component. So the health component will have a maximum health and a current health, so you store both of those. By default, when something is constructed, its current health is set to its maximum health. And whenever there's a collision between an entity that does damage and an entity that should take damage, you take the amount of damage from that damage component and subtract that from the entity's current health. So that's what's happening here. Also, if the player takes damage, this is what happens. So I just took 2 damage from this thing. Do I have a restart button? Let me just hit it again. Okay, so I just died. I think there's a little bug in my solution. I'll fix that for tonight when I give it out to you. But when Link takes damage, one of the important parts of this assignment, has anyone ever heard of invincibility frames when it comes to gaming? So here's one thing that's interesting. We're going to detect collisions on every frame, right? So you're detecting a collision between the player and an NPC that deals damage to the player. So what would happen if we just checked for damage on every single frame? Well, 1 frame is a 60th of a second. So let's just say I was touching that NPC for half of a second. Then that would be 30 times that the player would take that amount of damage. And so there's a bunch of different ways that we can get around this problem. Like, for example, some games, when you collide with an enemy, they actually push you back, so you can't take a bunch of damage right away. But what we're doing in this assignment, I'm not sure why that's not implemented here. It was when I checked it last night, is that Link, the player, is going to get some status effect. So one of those status effects is invincibility. And so when you get hit, what you're going to do is say, okay, if Link is currently invincible, then nothing will happen. But if Link is not invincible, he's going to take the damage, and then we're going to apply those invincibility frames. And the invincibility frames are going to be applied as a status, just like the lifespan was. So you're going to say, okay, Link gets invincibility for, say, 1 second, so it will be 60 frames. And then that will tick down. So instead of having just a lifespan system now, we're going to have a status system. And that will handle all of those things, those persistent statuses. So if you had quad damage or speedy boots or a speed potion or whatever, all of that will be taken care of in the status. But when it comes to the enemies taking damage, you could handle that by giving enemies invincibility frames. That's one way to do it. But I thought that for this assignment, another way that would be interesting to do it would be to actually remove the damage component of the thing that damaged it. So what happens with enemies in this game is that when the sword comes out, if the sword deals damage to an enemy, then for the remainder of the sword's lifespan, its damage component is actually removed. So if on the next frame the sword is still out and you detect a collision, well, it doesn't actually have a damage component anymore, so the thing won't take any damage. So I just wanted to illustrate the 2 different ways that you could accomplish this sort of thing, either by removing a damage component or giving invincibility frames. It's just some sort of game mechanic that you have to implement in order to make sure that these minor collisions for minor amount of times don't just repeat and stack up the damage like infinitely quickly. Okay, so that's the damage and the health, and up here there are some items in the level. One of them is a heart. If I pick up the heart, I will actually regain my health. Okay, so let's talk a little bit about these rooms. So up here, you can see that there are tiles in the level, and if I try and walk into this tile, then nothing is happening. So I think if I turn on C, yeah, so here you can see the collision box view, where this is how I'm actually colliding with the level. So Link's collision box is a little bit smaller than the tiles, and that lets me do things like walk up through these parts here. But we're actually introducing 2 Boolean variables to every entity in this assignment. One is whether or not something blocks vision, and 1 is whether or not something blocks movement. So what I'm going to do is I'm going to come down here to this one, and I'm going to turn the textures back on. So if I look at this section of the game, you can say, okay, well, this tree in here, there's no way I can get to that tree, because if I try and walk into these tiles, like, I'm just colliding with all of them, right? But if I cheat and I turn on the collision-based mode, or the collision view, then what I've done is I have introduced some coloring to the collision-based tiles. So if something is colored black, then what that means is that it both blocks vision and it blocks movement. If something is colored white, oh, an NPC caught up to me. Apologies for that. If a tile is colored white, that means it doesn't block movement and it doesn't block vision. If something is colored red, it means that... One second. These NPCs keep running. All right, that's why in the original Legend of Zelda, if you're not in the room, all the NPCs are actually inactive. Maybe I should have done that for this assignment too, but I didn't do that for now. But all of this just means to say that, okay, what I can do now is I can actually specify independently of vision or movement whether a thing's blocked or not. So just in the game now, I can sort of make these like secrets in the level where there are certain parts of the world that don't look like I could walk through them, but I can actually walk through them. And similarly with vision, let me just show you where this matters. So if I go back up here and I go into the left room, that's one of the ones, let me restart this because that's one of the ones that ran after me. So over here, these tiles are blue because they block movement but not vision. And so this is a good analogy for something like water. Imagine I'm on one side of the water, I'm just looking at you on the other side of the water, but this NPC can't swim, or like Link can't swim. So the water is blocking movement, but it's not blocking vision. And so I'll get to why these people are chasing me in a second, but I just wanted to mention that because there are 4 states of a tile now. We no longer have decorations and tiles. All of these things are just tiles, but every entity in the game now explicitly specifies whether or not it blocks movement, vision, one or the other, or both, or neither. So there's 4 possible states for a tile because of that. Let's see. Another thing that I have in this assignment are these black tiles, and these act as teleporters. So there are currently 3 of these black tiles in the world, and what happens is when you step onto one of these black tiles, it's going to choose a random black tile and teleport you there. And so if I walk up to this one, now I'm over here at this other one. If I walk up here, now I'm down at this one, okay? I currently don't actually have any checks to see if I'm teleporting myself to the same black tile. So sometimes that can happen. It looks a little awkward. Let me just get one of those examples. Or maybe I did? Yeah, maybe. No, okay, so I just teleported to the same spot. But just make sure that you teleport the player down a little bit from the black tile, because if you teleport them onto the black tile, they'll just be infinitely teleporting on every frame of the game, right? So that's another thing that you have to do. What else? There's a few other things. Okay, so one of the big things in this assignment that wasn't in assignment 3 are the NPCs. And so the NPCs in this game, right here you can see one of them here. It's I can't remember the name. I think it's a Tektite, and over here this is a Tech Knight or something. I can't remember what the actual Zelda names are. But the way we specify their behavior is through giving them an AI component. Now, this is not an AI course, as I specified before. This is like very, very basic level of AI. So we're going to have 2 different AIs in this assignment. One of them is a patrol behavior, and the other one is a follow behavior. And the follow behavior is quite intuitive, and it just means that, so for example, this NPC right here, this knight, has a follow behavior. So on every frame of the game, I kind of want to get rid of that one because it's in the way, but this NPC basically says if the middle of this NPC can see the middle of the player, then it's going to start walking toward the player. That's it. And so right now, because this tile blocks vision and movement, it's not going anywhere. But in the debug view, what I'm doing here is any NPC in the game that has a follow behavior, I'm just drawing a line from that NPC to the player. Okay, so you can use that for debugging. So what you have to do is you have to check all of these line segments of a vision blocking tile. So when we get to this part, I'll say a little bit more about it. But basically, you have a line segment, A, B, between the middle of link and the middle of each NPC that has a follow behavior. And then for every entity, you're going to have to do the little bit of math to form these 4 line segments that outline this entity, and then check to see if this line segment between the player and the entity intersects with any of those. And if it does intersect with any vision blocking thing, then it can't see the player. And as soon as I move up, let me zoom out a little bit here. As soon as I move up so this line doesn't intersect with any of those lines, then that thing does start to follow me. Now you can see here that the pathfinding is kind of bad. It does get stuck on things because it's literally just moving in a straight line towards me. But that's okay. We're not too concerned with this being a little bit dumb right now. We just want to implement that behavior. The other behavior, as we can probably see, go away, is this patrol behavior. So the patrol behavior, if I can zoom in down here, is defined by a certain number of patrol positions. So when you've got the sort of debug view on, you can see the 2 patrol positions of this NPC down here. And so the way the patrol positions work is that the NPCs that have the AI behavior of patrol will have a vector of XY positions and a index into that vector of the current patrol position that they're trying to head toward, right? So the entity will spawn. Let's say this is the first patrol position and this is the second patrol position. So wherever this entity spawns, it's going to start heading toward the first patrol position. And then when it gets within, let's say, I don't know, a few pixels of that patrol position, it's going to increment the index of the vector of points and start heading toward the next patrol position. So if this is the next patrol position, then it'll start heading toward there. And then when it gets to that, it'll increment the index, but it'll overflow back to the beginning, and it'll be heading back toward position 0. And so this is 0, 1, 0, 1, 0, 1. And so that is how that patrol behavior is implemented. And over here, we can see a slightly more complex version of that behavior where this NPC has 4 patrol points. And so right now, you can see that this NPC is walking around in this sort of rectangle. But if I had specified those points in a different order, then the NPC might be walking like in a diagonal fashion or whatever, right? So the order in which you specify those points does matter. And through the combination of all these things, you can actually get some pretty interesting things happen. So let me restart this level again, and I'll have to kill this guy so I can exist peacefully. So over here, what I have are 3 patrolling NPCs that block vision, sort of on different cycles offset from each other because they have different speed. And then this one over here has a follow behavior. So this NPC is trying to come toward me, but when any of these NPCs that block vision get in the way, this one starts to head back. And so it's kind of a fun game to just sit here and just like see if this NPC could ever actually make it to me because of these timings and stuff. And so that's pretty neat. I think that you can have some really interesting game mechanics just out of these really, really simple things that you implement. And I believe that might be it for my initial demo. Is there anything here I haven't explained? If there isn't, then I'll get to it when I get to the README file, basically. One other thing that you can implement for bonus marks that I have implemented in this assignment, which is related to the level editor for the project, is this. So if I left-click on anything in this game, I actually get this selected entity window that pops up. So this is really neat because what I do is whenever and I've modified the action class so that I can take in mouse clicks. I'll get to that when I get to the action class. But anything that I click on, if I've identified that the mouse click is within the bounding box of any entity, then I pop up this window. And then what I do is I just have an if statement for every possible component that we have in the game. And I just say, okay, if this NPC has the C transform, then draw all of the things related to that transform. If it has a health component, draw its health component. If it has a damage component, draw its damage component, etc. So this gives me this really cool view of all the properties of this entity. And I can actually like edit them in real time, which is pretty neat. But that's like the worst possible way that you could move something around. It's not a great way to do it. But you know, I can change the scale and stuff and the facing. It's pretty neat. I can give them more health, maybe knock that health, the current health down a little bit. Oh, sorry, this is the max health and the current health. I could change its bounding box, its inputs. I can fake that it's going to the right now, all sorts of things. And so implementing this box in IMGUI is, I think, worth 5% bonus marks for this assignment. And it will be a necessary thing for the level editor if you choose to do one. So right here, I haven't done it for this, but I probably should have done it to demo this, but I'll have it probably in the next lecture, is that when I click on this NPC, I should probably be like listing its patrol points down here, right? Because if you're doing this level editor for the project or for this assignment, one of the things that you have to be able to do is set those patrol points from within the level editor, right? So you might have a button down here that says add patrol point, and then you'll click where that patrol point should be in the level. And then that will affect the behavior of the NPC. And one more thing is I have actually implemented a very, very basic version of a level editor in here. And so what I've done, and this is just to give you an example of what you could do for the bonus part. Just give me 1 second for the question. So over here, what I've done is if I click on any of these things, then I can place it in the level. So I can start placing these things in the level. Now I think if I right click or hit escape, I stop placing them. Yep. And now if I click, then what I can do here is for every possible component, if it doesn't have it, then I can add it. So like this entity doesn't have a health component, but now I can add one, right? And now it has health. And then I could save that out if I want to. I could add a damage component to it. So if this was a lava tile or something, I could say, oh, well, that'll do 10 damage when someone steps on it. And so this is a really easy way to implement basic level editor functionality. I can also delete things here. I can't remember exactly how. Like I can click delete. I can also go into like delete mode and delete a bunch of things. I can copy and paste different entities and that sort of thing. I'll get into more of those details in the next lecture. But how you implement this for assignment 4 or for the project is completely up to you. It just has to be completely feature complete so that you can actually load levels, edit anything that you would need to be able to edit in the level, and then save the level. But for assignment 4, if you got like this far with the level editor, as long as you can save and load some stuff, you'll get full bonus marks for this assignment, and then you'll also be finished the level editor for the final game. Maybe not finished, but most of it anyway. Okay, yes, you had a question.
I just had a question regarding the vision stuff.
Yep.
So when the knight saw you,
Yep.
he followed you and he did not stop. But when he went to the right side of the screen, the crab like it saw you and then it stopped seeing you and then it moved
Yep.
back. Are there different types of following behavior?
No, it's the same thing, but what's happening here is that these NPCs block vision, right? So whenever these lines collide, he can no longer see me. And so he stops moving toward me and goes back. And I forgot to demo this for this one. So you're right, I should have done that. This guy here, if he follows me, but now he doesn't see me and he goes back to his home position. So you're right, I forgot to mention that. The follow behavior, as soon as the NPC cannot see you anymore, they go back to their home position. Yeah, good question. Any other questions before I start to get into the README file? Okay. All right, so all the same stuff up here at the start of the README, so I'll skip down to here, which is the assets. The only thing that's different with the assets in assignment 4 is now we can load and play sounds. And I didn't demo that, but in the assignment, if I go in here and just look at the scene properties, so up here, the sounds, you can actually play the sounds from here. So this will iterate over the asset manager, and now I can play the music, stop the music, play or stop any of the sounds in the game. So that's the only difference. And in that little debug menu, I've just got the ability to stop or play those sounds. So that's assets. That's all the same. The assets file, I don't even need to open that anymore. There's just one other type of thing, which is called a sound. Then you name the sound, and then you give the OGG or the wave file for the sound. Okay, so obviously the most important thing is the player for this assignment. So the player in the game is represented by not Link, for legal purposes, which has several different animations. Run down, run up, run right, stand down, stand up, stand right, attack up, attack down, and attack right. You must determine which direction and state the player is currently in and assign the correct animation. So let's go have a look at all of those. So this is stand down, when Link is just standing there not moving. Then there's stand up. There's also run up and run down, and those are just a few frames of animation where the feet wiggle. There's stand left, stand right, run left, and run right. And then there's also attack right, attack up, and attack down, where Link sort of does this thing. The sword is a completely separate entity from Link, and when you press the attack button, the sword just spawns out in front of Link. And if I show this mode, you can see that the sword is its own entity with its own bounding box there. Alrighty. The player is assigned the following animations in the direction facing. Please note that left will be accomplished by mirroring right. So that's by setting the X scale to -1. You're all familiar with that from assignment 3. And so these are just the states and the names of the animations that have to be assigned when those are there. So stand in a particular direction, that's when no input is being given. Run in a direction, that's when the player is actually moving in that direction. And attack in that direction is when Link is attacking, and that lasts for some duration, which we'll get into when we spawn the sword. The player has the typical up, down, left, right, WASD keys, with the space key being the attack key. The player can only move up, down, left, and right at any time during the game. And so I cannot move in diagonals like I could for assignment 2. So if I'm moving to the left and I hit down, nothing happens there. Why? Because I can't move in a diagonal. And so what happens is, if you're holding two diagonal directions, like up and right, or down and right, or down and left, whatever, you would just have to choose a priority. So am I going to maybe take the key that I've already been holding? Am I just going to prioritize horizontal movement over vertical movement? I am not enforcing any of those things. The only thing is that if you're holding both left and right, then you do nothing. If you're holding up and down, you do nothing. And if you're holding diagonals, then you only go in one of those directions. Actually, let's just say we prioritize horizontal movement so that it's the same as the assignment, or as the solution. So prioritize horizontal movement if you're holding both. So what you have to do is, you have to have a little bit of logic there in the movement system that says if both of these inputs are active, then choose one or the other. If opposite directions are held, the player will be given one of the standing animations. The player can only attack once its current attack animation has finished. And so the attack animation has a certain duration. And you can see here, I can't remember what that duration is right now, but I can't just, I'm pressing the button probably 3 or 4 times as fast as the attack is coming out. And I can't attack again until that animation is finished. So you have to do a little bit of logic to figure out that. The player collides with tile entities in the level whose bounding blocks box movement and cannot move through them. So in your collision system, instead of just checking for tile like you did in assignment 3, now you'll just have to check that Boolean on the tile that says if it blocks movement. The player will be given a bounding box of a size specified in the level file, just like assignment 3. The player will be given a C health component with a max health that is specified in the level file. When the player's current health is less than or equal to 0, the player respawns and the Link die sound should play. let's give an example of that down here. Okay, so that's what happens. You just respawn in the middle. If the player has a invincibility component, it takes no damage from enemies and its sprite is made transparent. So the thing that's not working right now, and I'm not sure why that is that Link is actually not transparent for some reason. So you can see here, I'm not taking damage infinitely fast. It looks like my invincibility frames are about 60, so it's about 1 per second. But Link should be transparent there, so I'll try and fix that for the solution. The duration of the component is reduced each frame, and when the duration reaches 0, the component is removed, making it vulnerable to attacks again. So here it doesn't specify the amount of frames, so let me just type that in. Oh, I think I did that in the collision, so we'll see. When the player collides, yeah, okay, so it's 30 frames, so it's half a second. When the player collides with an enemy while not invincible, the player's current health is reduced by the enemy damage amount, the Link hit sound should play, and the player is given an invincibility component which lasts for 30 frames. Okay, other entities. Each tile and NPC in the game specifies 2 Boolean values of whether it blocks movement and whether it blocks vision. If a tile blocks movement, the player collides with it and cannot pass through it, as well as NPCs also collide with it. But you don't have to worry about pathfinding around objects in this game. If the NPC is just walking right into it, if they're chasing Link, that's fine for this assignment. If the entity blocks vision, then it affects the line of sight. The C bounding box has 2 new Booleans to reflect those changes. So if we go really quickly over into components, and we go to the bounding box component, then we have the size and half size like we did before, but we also has blocks, block move, and block vision. So that's where you'll get those. When the player steps onto a tile with the black animation, they are teleported to a random black tile on the map. If you want to go ahead and implement that little bit of extra logic that says I can't teleport to my own tile of where I just came from, feel free to do that, but there are no marks associated with that. And again, that black tile is this one right here. So there are currently 3 of those on the map. Now, in this game, you could think about having a background, which is a bunch of tiles, right? But right now, the background is just given a color. And so that's how we're accomplishing this background, is that when I give the clear screen command to SFML, there's an optional parameter in there to set the whole screen to a given color, and that color is just this color that's associated with Zelda, right? So these are not actual individual tiles in the background, just like the blue color for the background in assignment 3 was just the default color of the window. This is now the default color of this window. Attacking. When the player attacks, a sword appears for 10 frames in the and then disappears, approximately 1 tile away from the player in the direction they are facing. So let's zoom in on that. So when I hit this, right now, without the bounding boxes on, it almost looks like the sword is attached to Link, but they are completely separate entities. And so what I did is I just took Link's position, added the size of the bounding box, and put the sword over there, right? So approximately 1 tile over for 10 frames. So the sword is given a lifespan and a damage component, and then Link's animation is also set to the attack animation when that happens. The player's sword should be given a bounding box equal to its animation size. When the sword collides with an enemy, it deals its damage component worth of damage to the health of the enemy that it collides with. The sword should only do damage for 1 frame, and then its damage component should be removed so that it does not deal damage for every frame that it overlaps. Now, here's something pretty interesting, and this is a game design decision that you would have to implement. So, in the original Legend of Zelda, if there are multiple entities on the same tile, and that happens a lot, because the entities don't collide with each other, and oftentimes there could be 2 or 3 there, if I swing the sword, should everything on that tile take damage? Well, in Zelda, yes. But it's a game design decision whether or not you want that to happen in your game, right? So if you want everything on the tile to take damage, then what you would do is you'd iterate through all the enemies, find out all the collisions, take away all of their health, and then at the end, you might remove that damage component from the sword. Versus, if at the time of the first collision, you took away the health and then removed the bounding box, or then you remove the damage component from the sword, then because there's no longer a damage component on the sword, then nothing else on that tile would take damage. So I'm not enforcing either one of those. If you think everything on the tile should take damage, then do it that way. But what I'm saying is the important part is that the sword should only deal damage on one frame. But however many things take damage are up to you. Another interesting gameplay mechanic that turns out to really introduce a cool skill, like it raises the skill ceiling, is that I can actually attack in the original Legend of Zelda, which I can't do because of this spec. If I did this, then I can attack something in front and behind me on the same attack. So I go, see that? Like the bounding box appears on both sides. Your sword should do this. So if you're walking around and you attack and then you move down, or you go like this, I should see your sword appear both in front and behind. So it's not just that it spawns in front of the player and then it never moves, because if I was moving and attacking, I would just walk right through my sword. So for the whole time the sword exists, it should be placed in front of where Link is facing. So that's just a little bonus there. But no, because of what I've said in this assignment, if I were to stab someone in front of me, at the end of that frame, the damage component would be removed. And then when I turn around with the sword, the damage component is no longer there to hit those things. So in this assignment, that can't happen. When the sword is swung, the slash sound should play. When the sword collides with an enemy, the enemy hit sound should play. When an enemy's health is reduced to 0, it should be destroyed. When an enemy is destroyed, the enemy die sound should play. NPC entities. NPCs will be given an AI behavior in the level file, which will either be follow or patrol. And I'll show you all the syntax of that when we get to it. Follow means that it should follow the player when it's direct line of sight, or sorry, when the player is in direct line of sight. I should, or head back to its original position when not in line of sight. When an entity is at its home position, it should not oscillate. So remember when we talked about the arrival behavior of seeking, or of steering behaviors? That's not only for steering behaviors. Anytime we have a destination, we have to make sure that we detect whether or not we are at our destination by a larger amount than the amount of movement we do each frame. Because if we allow ourselves to jump over that detection amount, then we can oscillate back and forth at the destination. So make sure you're not oscillating. Patrolling means that it will move toward a series of patrol positions, looping back around to the start when the final one is reached. An NPC has reached its patrol position if it is within a distance of 5 from it. And just keep in mind that if your speed of your entity is much greater than 5, then you could have an oscillating behavior. But why I said this is because this is fine for this assignment. This fixes the oscillations because we won't be giving any of the NPCs a greater speed than 5. So you don't need to worry about that too much. Tiles. Tiles are essentially identical to the tiles in assignment 3. So I won't read that because that is literally copy and paste from assignment 3. Drawing. The window is given a fixed size of 1280 by 768. And you may ask yourself, why isn't that 720? That would make a true 16 by 9 full screen aspect ratio. The reason is because 720 isn't divisible by 64. And so what this does is this gives us a full 20 by 12 tile resolution. So each of these rooms is 20 tiles wide and 12 tiles high. And that's sort of a pleasing aesthetic without needing to get we can't have 64 pixels line up with a 16 by 9 aspect ratio in this way, in any sort of modern resolution. So that's why I did that. Rendering of the entity, you could also ask, why didn't I just make the rooms 16 tiles by 9 tiles? Shut up, that's why. Basically because it would be a little small, right? You just have this tiny window. Anyway. Rendering of entities is given for you, as well as debug rendering, which can be toggled with the F key. I think that's wrong. Yeah, it's the C key. And this is the T key. Okay, so collision rendering and texture rendering. You are required to change the camera position of the game to alternate between 2 modes based on the mFollow variable. So over here, in debug, this follow cam, this this input box right here, this alters the m_follow variable. So in the camera system, you're going to read that variable. If it's follow, then it should be following Link, in which case you would set the center of the room view to be on Link's position. If it's false, then you would figure out the view needed for whatever room that Link is in. Okay, and the rooms follow, finally time to explain that. Each level is split up into individual rooms given an Rx, Ry coordinate. Room Rx, Ry is defined by the rectangle Rx times W, Ry times H, W and H, where W and H are the window width and window height, respectively. I'll read this and then I'll go back to the game to give an example. Each tile is given a tile Tx, Ty grid position within a room. So tile 0, 0 is the top left tile of the room that it's in. Okay? By default, the grid cells and all tile cells are 64 by 64 pixels. When NotLink moves to a new room, the camera should center that to that room if it's not in follow mode. So what I mean by all that is that the coordinates of Link, what you will do in your camera system, is you will have to figure out which room Link is actually in. So if I take my current position, let's say this current position is like, let me turn off the grid. I'm approximately what? 500 pixels over, 500 pixels down. So if this window is 1280 wide and 768 down, which room should I be in if I'm at 500, 500? Well, one way to do that is integer division, right? So you take 500. Which x position of the room is 500? Well, 500 is in between 0 and 1280, so that's the first room. It's room 0 in terms of x. So the Rx of where I am right now is 0. If my y position is approximately 500, then it's also the same case, that I should also be in room 0 in the y coordinate. So it's Rx and Ry are both 0, 0. But if I move one room to the left, what is that room coordinate going to be? Anyone? Hand up. If I'm in room 0, 0 now, and I go one room to the left. Negative 1, 0, right? So I've gone one to the left, which in SFML is going to be negative, because I'm going to the left. So this is room negative 1, 0. And all of the negative 1 x coordinates for rooms are going to be between 0 and negative 1280, right? And so that's, you can figure out that math. I don't want to give you the exact formula. You've got to do something for yourself on this assignment, right? Similarly, if I were to move up, now this is room 0 in the x and negative 1 in the up, right? And this would be room negative 1, negative 1, and so on and so forth. So you would have to figure out those room positions. Oh, Jesus. Once you figure out the room positions, then you literally just multiply the room position by the width, so the x by the width and the y by the height, and now you have figured out the rectangle that you should set the camera view to. So that should be not super difficult for you. And then the tile positions are relative to that room. These are not global tile positions. So like this room and this room, okay. So the solution is wrong, because up here I've actually got negatives for the tile positions, but that's incorrect. They should all be given positions relative to the room. But yes, if you hit the grid view, these are global tile positions, which I'm not using, so I apologize for that. But Do what I say, not what I do, I guess. Okay. Let's go back. Bonus, up to 10% for implementing the selected entity UI plus level editor, and up to 5% more bonus for cool functionality or visuals that you choose to put in this game. So lots of room to get 100 on this assignment. You just can't go over. These are just some miscellaneous controls. And what I wanted to show you real quick over here in the marks file is down here, I've specified this. So you do have to do that basic GUI functionality, but the level editor and selected entity UI that I did, doing that is up to 10% bonus marks and then 5% more. And again, that can only get you up to 100, but at least it can fix some other things that you did wrong. All right, so I'm not going to go over the assets file because that's the same. I'll just show the assets file. In the bin directory, we have our assets, and now we just have sounds on top of everything else. But I do want to really quickly show the assets class. Now I know normally I go into the code after I've done the whole README file, but this is just what I have. So here, this is the assets class now, and we've added 2 new things to it. Those 2 new things are a sound buffer map and a sound map. And I may be getting these backwards, so I apologize if I do, but I believe that the sound buffer is the actual audio data that is loaded from the file. Then a sound object in SFML is a sort of thing like a sprite, but for audio, where it's a lightweight object that points to the sound buffer data, and then the sound object contains other information like where am I currently in the playing of this sound, so I can pause or play it, and also the volume level of that. So the sound buffer data is the actual audio data, and then the sound is all that metadata on top for actually playing that audio. And so if you want to actually play a sound, then what you would do is down here, you would call getSound, and you would say getSound.play. Okay? Now, something about sounds in SFML is that in order to play a sound for its whole duration, the lifetime of the sound object and the sound buffer data should be at least as long as how long as you want to play it. So if I just created a function called playSound, and in that function, it loaded the data and started to play it, as soon as that function ended, like a trillionth of a second later, the sound would stop playing because all of those objects would be destructed by the exiting of that function. And so one of the cool things about having this assets class is just like the fact that we're only storing texture data once and reusing it everywhere, we are absolutely certain that the sound data is only loaded once and then used everywhere as well. Now, the way that I have this configured is also to have the sound objects persistent as well. So what that means is, if I try and play the same sound a bunch of times, because I'm repeatedly calling play on the same sound object, it is just restarting that sound back to the beginning. But if you wanted to, for example, if let's say it's some like war zone or whatever, and there's a bunch of different explosions going off, you would want each of those explosions to have its own explosion played to its entirety. You wouldn't want like the first second of the 3-second explosion to play and then restart over here. So just to let you know, this current architecture that we have does not allow for the simultaneous playing of multiple versions of the same sound. In order to do that, you would have to put a little bit of infrastructure on top of this, but this is just fine. It's really simple and it works for our assignment. So I just wanted to mention that. So that's all about sounds in this assignment. Okay. Next, the level specification file. The player specification is very similar to what it was in the previous assignment. So we have an XY position where it spawns, its bounding box size, its speed that you should use when you move, and its maximum health that it should be given at the start of the game. And if you go over here and you open up one of the level files, so level 1, at the end where the player spawns in the middle of the screen. It has a 48 by 48 bounding box. It moves at speed 5, and it's given 3 health to start. So that's the player specification. The tile specifications are similar to assignment 3, but it has the extra thing of now we have a room x and y variable as well. So each of the tiles is given a room x and y and a tile x and y within the room, and booleans of whether or not it blocks movement. So for example, if I go right up here to some rock bottom middle or whatever this means, it's in room 0, 0 at tile position 15, 0, and it blocks movement and it blocks vision. Oh, and I should mention that just to confuse you all, we're back to 0, 0 being in the top left, right? Because in this game, moving up, down, left, right, you can move arbitrarily, but I hope you understand why I did that for assignment 3 to have 0 at the bottom, because it made the math a little bit easier. Okay. Let's go to one of those black tiles. So the black tile here, you can see that the difference is it doesn't block movement or vision. So that's how you specify tiles. Now we get into NPCs. And so the NPC is where it starts to get not complicated, but just a little bit more. So we have the animation name. That is the animation that the NPC should play. So in this system, we are not, for example, changing the animation of the NPC if the NPC were to attack, right? The NPC's animation is just on a loop the whole time. For the project, hopefully it's a little bit more complex than that. So this is the spawn location, the room X and Y of the spawn location, just like the player, whether or not it blocks movement or vision. So this is exactly the same as a tile so far, but now we get to the difference. The NPCs are given a health. This has to be greater than 0 or it'll just die when it spawns. It's given a damage component, and that's the amount of damage it will do when it collides with a player. And then there's an AI string, and that string will determine the following parameters, okay? So whether that string is follow or patrol will determine what comes after that in the remainder of the line, okay? So if we go over here to the level file, I've defined a few NPCs here. Yeah. So for example, this knight, following this string, so this string here is the type of AI that this NPC should be given. If it's follow, it's super easy. The only other parameter is what speed it should follow the player at. And so this is 1 per tile. And so that's it. If AI is equal to follow, couldn't be easier, just the speed that you move at. But patrol involves a few other things. So the first thing after patrol will, just like follow, be the speed that it should patrol at. Then you will give it the number of patrol positions, and following that will be 2 times n values, which are the x and y values of the n patrol positions. So right here, for example, this is the tektite on the first screen, and this says, I want you to patrol at a speed of 2. There will be 2 patrol positions. They will be 3, 9, and 7, 9. Okay? So that's it. And these are the positions within the room that it spawns. So just so you know that, because there are no room positions here. This one says patrol, and let's actually look over here. So if I turn this on, so the patrol positions of this guy should be 15, 7, 17, 7, 17, 10, and 15, 10, if I've done everything correctly. And okay, so what I've done is I actually specified the bottom left one first. So it's 15, 10, 15, 7, 17, 7, and then 17, 10. Okay, so that's pretty easy. You just have to, in your level, load level file, what you have to do is like, okay, if it says NPC, read all of these things, which will all be the same. And then if the next thing is patrol, get ready to read all of these things. But if it's follow, only read the next thing. So you're all familiar with how to read from files like that. And then I spell out this example, which I just did for you, but it's just there in case. All right. So I already said this, I believe, but just keep in note that the SF sound objects can be played with .play and stopped with .stop. However, in order to play, the sound object must persist for at least the duration of the sound that you want to be played. If you simply allocate a local sound object and then call sound.play, it will stop playing as soon as the sound object goes out of scope. Calling sound.play on a sound object that is already playing will restart the sound, not start playing another one. So this will be assets get sound.play. That's how you'll play sounds. Here are some hints. I'll look at the code before I go over the hints. So let's go down here through the code again. I will close these things. The action class has been given one extra variable, and that extra variable is this position. Because if you want to implement the clicking of stuff to show that NPC, then in the game engine, what I've done, the game engine is if the mouse button is pressed, now I have an action which is left click, middle click, or right click. Those actions are start or end, and then I pass in the position of that. And so if you want to, these are already done for you. You can just say, hey, if the action was left click, now you get the mouse button of that click. Alrighty. So that's the only thing that's changed in action. Nothing's changed in animation. I showed you assets. Components. There are new components for the follow player and patrol. So the way the patrol works is there are just a standard vector of vec2f positions. And so because these are public, when you're reading in from the level file, you would just stick all of these positions into here and you'd be good to go. Then the current position is the index into this vector of the current place that this NPC is heading toward. And so inside your AI system, when you think that you have reached the current one, then you would add one to it and wrap it around if it's at the end. Okay, cancel. So that's components. Entity, entity manager, game engine, main, all of those are the same physics. This is where something is different. So physics has get overlap and get previous overlap again. You can literally copy and paste from assignment 3 those two functions because all of our physics are still the same. This is another function called isInside. IsInside takes a position and returns whether or not it is inside the bounding box of the entity. And so you can use this function to implement that UI click to say, is it inside an entity or whatever else that you want. This is the line intersect function that we went over in great detail in the line segment intersection lecture. And these A, B, C, and D, those are the same. So that's line segment AB, line segment CD, straight from the notes. And so you just have to implement that function. And then the intersect struct that you return has that result and position. So again, the result is false if they don't overlap. And if it's true, then you have to include the position of the overlap as well. Now, once you have line intersect done, then you can do entity intersect. Entity intersect will take in AB, a line segment AB, and return whether or not it intersects with any of the lines of the bounding box of the given entity. So that example, which I've already showed, but I'll show again, if I come over here. So line segment AB here would be A would be the center of link, B would be the center of the knight, or vice versa, and then the entity would be this tree. So you would have to figure out the line segments A, B, C, and D. Then for each line segment AB, BC, CD, and DA, does AB intersect with any of those? Right? Now, sorry, I just called this A and this B, but then I gave this one AB. So this would be C, D, E, F. So you're going to have 4 points. You have to figure out those 4 lines and see if any of those lines intersect. And that's how you'll do your line of sight calculations, is by, for every entity that has the follow behavior, take the player and the entity and get their positions, and then pass it in, and then loop over every entity. If that entity blocks vision, call entity intersect with those things. So that's physics. And then I think the only thing that's left is scene Zelda. So I'll go quickly through all the functions here. So the constructor just calls init. Just like assignment 3, you're going to have your load level function, which is called from within init, and then you have to register the rest of the actions here. So I don't have any of the movement keys or the spacebar registered. You can put in those. The load level function is going to go through, so first of all, it resets the entity manager, and this is almost identical in its logical scope as assignment 3, just that there's that little added extra of now you have to parse the NPC behaviors. That's it. And instead of this grid to mid pixel function, I've just replaced that with get position. Get position takes in the room XY and the tile XY, and you have to return the center position of the entity if it were to be placed at that tile position. Spawn player, this is basically identical to assignment 3, and inside scene Zelda, I again have this player config struct where you can read all the properties of the player from the level file, and then that's what you call to actually spawn the player. And by default, I've given you some, hard-coded things, but you have to remove all of that. This is the spawn sword function, and the spawn sword function takes an entity as its parameter. That parameter is typically going to be the player, but by putting in a parameter, this means that technically you could have any entity with a sword if you wanted to spawn a sword at that position. And so you have to implement all the things related to the spawning of a sword. This is the update function, so you have to do the same things to this as assignment 3, sorry. Movement function, you're all familiar with the movement system by now. The do action system is the same as assignment 3. The AI system is new. So in here, this is where you would implement the follow behavior and you would implement the patrol behavior. So you'd loop over all of the things tagged with NPC. Then if they have the follow component, you would do the follow behavior. If they have the patrol component, you do the patrol behavior. This is the status system now. So this is where you do lifespan. You can still copy and paste lifespan from assignment 3, and you would also implement the invincibility frames there. Again, the collision system is probably where the meat of the programming is going to go, but a lot of this is actually the same as assignment 3. So like you can almost replace like, okay, bullet collisions with whatever. This is if the sword collides with an NPC or if the player collides with an NPC. Also, it's a little bit simpler in its collisions because now you don't have to detect whether or not you're coming from the bottom or the top, you're just blocking movement. There's no collision in this assignment with tiles that spawns any extra behavior. Animation, there's a couple of things here. You would just copy and paste from assignment 3, of course, to do all the actual animations, but now the attack animation lasts for a specific duration, things like that. The sword has to be placed no matter where Link is facing. Even if I attack and then turn, it should be there. So that's where I would implement the animations. This is the camera system. So I've already put in this for you. So if it's following, otherwise that. On end, this is to clean up for the function. And then the rendering has been done for you. The only reason you would need to touch the rendering is for the bonuses, for the, I knew there was a reason. So the bonuses for any visual style or whatever. Then there's the GUI system. You can copy and paste from assignment 3 and edit that to your heart's content. And here, there's just this helper function. One other thing that I will mention is that in my solution, which is here, I actually have a separate scene for a level editor. So the way that I've done that, if I go over to the solution code, this is the source solution, I have created a scene level editor, okay? And that has a bunch of stuff related to level editing that the standard playing of that scene does not have. And so if you are implementing level editor stuff, I highly recommend adding your own scene, making it selectable somehow from the main menu. Like just there's an option there. You can add an option just called level editor. That'll tell me that you have actually done a level editor. And then all that'll be done for the project. So I highly recommend, like in the level editor scene, you don't need to worry about collisions or whatever, right? Your level editor scene should just care about editing levels. So it shouldn't be as complex as the gameplay scene. And I believe that's it. Oh, one other thing is that when you're clicking, I got to restart this. I didn't make a back to main menu button for the level editor. This might be the only tricky part. If I'm up here and I click this NPC, okay, that worked, thank God, because I want to show you. Where you click on the screen is not the same as where you click in the game world, because the camera is moving around, right? For example, if I have the follow camera on, if I were to click right here, and then I move and I click right here, my mouse hasn't moved. But the place in the game world that I'm clicking on has changed. There is actually a function in I think it's on the window. So the SF render window has a function which is like window to world, I believe. And so if you pass in the mouse coordinates as the parameter to that, it will return for you the coordinates in the game world where that would be based on the current view. So you don't have to do all of that math. There is a function, and it's like world pause or window to world. I can't remember exactly what that function is, but that function exists for you. And up here, for example, if I go back to room view, right here, if I click right here, that's close to 0, 0, right? But if I move up and now I click here, even though my mouse hasn't moved, this is like actually like 0, -768, right? So you have to be sure that things work on screens that are not just the default screen in order to get all the marks for that. But not only to get the marks, but also later on, when you go to build the level editor, you would want your level to be bigger than just one screen. So you want to get that working as soon as possible. Great. I'm always excited for assignment 4 because it's like where you get, like it's almost a working game at this point, right? Once you get assignment 4 done, and then a few extra things for the project, basically the only thing left to make a decent 2D game is just assets and level creation. It's like, it's crazy how powerful this ECS stuff is. So hopefully you're starting to see that. And I will give more details about the level editor and some tips on how to implement that in the next lecture.